Hello friends, today we are going to perform an experiment to determine the frequency of an AC signal using a sonometer. So this is a very simple experiment in which we are going to find out the frequency of AC signal which is provided at our homes. So first of all, for this experiment we need a wooden bench which looks something like this. There is one fixed nail at its left end and a pulley towards its right end. Now we can place two wooden blocks with sharp edges on this and tie a soft iron wire like this. Towards the right end we have one hanger on which we can place different weights to adjust the tension in this wire. Iron wire doesn't look blue in color, but just for the representation and better contrast, I am showing this with the blue color. Now, along with this, we also need an electromagnet. There is a copper winding around this metal rod. This is held by a stand just above this metallic wire in between these two wooden edges. This electromagnet is powered by the electricity. So in between we use a step down transformer. At home we get 220 volts, which after step down we get around 5 to 6 volt for this electromagnet, but the frequency remains the same. Now let us just lower this a little bit close to the wire, add some weight in the hanger towards the right end, move these wedges towards the outer end. Now switch on the apparatus and start shifting these wedges towards inward. As you start shifting at one position, you will feel that this wire is fluttering. If you move them a little bit more inward, the amplitude of its vibration will increase. In case if you further go inward, this amplitude will decrease. So you need to fine tune your position where the amplitude of this flutter or of this vibration is maximum. Now switch off the system and measure the distance between the sharp wedges on these wooden blocks using this scale, sometimes provided with the apparatus, or sometimes you can use a separate ruler for measuring this distance. After that, move these wedges inward and then switch on the system. As you switch on the system, flutters start again. In the first step, you have observed its reading while moving inward. Now we will shift these blocks outward and try to find the position where the amplitude of this flutter is the maximum. Now again we will switch off the system and measure the distance between them. Now with all these readings, we can come to make our table. In this table, in the second column, we are going to write the load which we applied in the hanger. So let's say we started with 1 or 1.5 kilograms at the beginning, and then write down the length of the wire at resonance when the amplitude of vibration is the maximum, in the condition when you were moving your wedges inward, and in the next column you are going to write the length of the wire at resonance when we were moving our wedges outward. Principally these should be the same, so we can take the mean of these, and in the final column, using this formula, we can find out the frequency of our AC signal. So there are still some pending things which we don't know. We basically don't know this value m. This quantity small m is the mass of the wire per unit length. So take a piece of the wire, the same wire, and then measure its weight. So basically you now know the mass of the wire and measure the length of the wire, and finally you can calculate this quantity small m, which is mass per unit length, in the SI units of kilogram per meter. So in this way you can finish one set of observation. Similarly, we can increase weight in the hanger towards the right end of our apparatus and keep observing these readings for them as well. And finally, with all these 4 values of this frequency, we can calculate the mean frequency of the AC signal. The frequency of AC signal in many countries is 50 to 60 Hz. Let us consider this is 50 Hz. So we can calculate the percentage error using this formula. Thanks for watching. Please don't forget to like and share my video and subscribe to my channel. Have a good day.